Listed below are the ages of actresses and actors at the time they won the Oscar. The data are paired according to the years that they won. And what that means is that the age of the best actress, 28, is paired with the age of the best actor, 62, because that is the year that it was given to those two people, 28 for the actress and 62 for the actor. 32 for the actress, 41 for the actor, 27, 52, and all the way down to 21, 62, 35, and 29. Paired means that they have to go together. And what does that mean by going together? Well, I'll show you in just a second, but you got to make sure that as the data is given to you is how you put it in. And the reason why we need to put it together is when it's paired is that we're trying to find the difference of each one. So dealing with dependent samples like this, we want to find the mean difference. So when we put our numbers into the calculator, we can find the information much quicker. So we're going to be using a 0.05 significance level to test the common belief that best actresses are younger than best actors. So let's start setting up our hypothesis. So we have our null and we have our alternative. And again, like I said, we're dealing with a mean difference. So we're going to be dealing with a mean difference. So mu sub d, so mean difference. And it's going to be equal to 0. Because equality for the null, typical. And then for the alternative, mean difference comes from right here. The common belief that the best actresses are younger or less. Because it's here, younger, less than in age. And our significance level, alpha, is 0.05. So now, like I said, we're going to be using our calculator to type in this information because it does make things a lot easier. So here's our calculator, and what we're going to do is we're going to go to Stat, edit for the list, and we're going to type in our list as it's given to us. So 28, 32, 27, and so on will be paired with the second list, 62, 41, 52, 41, and it has to be put in order. So I just did it straight across. You could do it straight down, but as long as each number is paired with their corresponding number from the actress to the actor, it's okay. Now, we still got to find the mean difference. Now, you can subtract them one by one and get L3, which will work, but there's an easier way. And here is that way. What you're going to do is we're going to do second and 1 for L1 minus second and 2 for L2, and then STO for store, second, L3. And now all the differences between the ages are given. And you can always go back to stat and edit just to see L3 with all the differences between the ages. Now we can get on to the hypothesis test. And since we're just dealing with L3, we're going to go to stat, tests, and we're just going to do a t-test. And again, we have data, no statistics. Our mean is 0 because that's what it is right here for the hypothesis. The list should be L3 if it's not, just second and 3 to give you L3, frequency 1, and then the alternate hypothesis symbol, which is less than. So we're going to use less than. And then down to calculate. It'll think about it and give us the test statistic, t, and the p-value, which is 1.6, which cannot be. So that means we need to look down and see that it is e to the -4th, which means we're going to move the decimal place over 1, 2, 3, 4 spots. So it'll end up being 0.0002. So t-stat, t equals -4.71. And then we are going to do our p-value. So let me just get rid of the calculator for a second. And so p equals 0.0002. And now I'm going to use the p-value method to test the claim, see if we reject or fail to reject. So p compared to alpha. So 0.0002 is less than 0.05. So since the p is low, we reject the null. And as is always, when we reject or fail to reject, we should state our claim in a sentence or so about what happened, just so we can see it better. So I'm going to go here and type in what we've uncovered. And since we reject the null, that means we have enough evidence. So we could say that there is sufficient evidence to support the claim that best actresses are younger than best actors when they win the Oscar. So we have our conclusion from the hypothesis test, so we can go on to the next part. It says, what do the results suggest about the age of winners? This is kind of just restating it a little bit more clear. We can say that the results suggest that best actresses win when they are younger, and best actors win when they are older. So just to emphasize here, when you're dealing with the mean differences, you got to put the numbers in paired how they are written out or how they're given to you. If you move them around, it's going to give you wrong answers. So be careful when you're typing in your numbers to the calculator that each number is paired to its corresponding alternate on the other side. But that's all you have to do for these.